4.1 Transformations of conic sections. Today we are going to describe and graph transformations. We are going to identify their domain and range, and we are going to be able to identify the vertex of a parabola or the center of a conic section. Our key ideas today are when we are given a parent function of f, so f of x minus 0 plus g of y minus 0 equal to 0. The graph of f of x minus h plus g of y minus k equals 0 will be translated h units to the right and k units up. So when we are looking at that, our h and our k are going to determine right and left, and our k is going to determine up and down, and that's going to vary based upon the conic section that we are looking at. Please, please, please remember that anything inside a parenthesis is going to move opposite the direction that you think. The first conic section we want to take a look at is a circle. So if you have two cones on top of one another, we are looking at the circle, which is we take a slice right in the middle of one of those cones. The equation for a circle is x minus h squared plus y minus k squared equals r squared. The center is always at hk and the radius is always at r. So to find the radius, you need to take the square root of r squared, and to find the center, you want to use the opposite of your h and your k. So the parent function we're looking at is x minus 0 squared plus y minus 0 squared equals 25, and it is graphed to the right. We now want to take a look at x plus 2 squared plus y minus 4 squared equals 25. So the first thing that they want us to do is they want us to find the center. So this plus 2, remember your h always coordinates with your x, so your plus 2 is going to tell us that it is going to move left 2. When we look at this minus 4 over here, your y coordinates with your k. It's inside, so it's going to be opposite. It is going to move up 4. So from our center, we can move left 2 up 4, and we can see that our new center of our circle is at -2, 4, which you should see corresponds nicely with how we moved. We then need to state the radius. So if we take the square root of 25, because that's our r squared, we can see that our radius is 5. So we want to count 5 units in each direction, up, down, left and right, from our center in order to graph our new circle. So then you want to connect your points as nicely as possible, and you just graphed your new circle. It then asks us to identify the domain and the range. So remember that the domain of your function pertains to your x values. What is the smallest x value that your graph touches? What is the largest x value? So your domain is -7 is less than or equal to x, which is less than or equal to 3. Your range pertains to your y values. So when we draw our dotted lines along our highest and our lowest, we get our range is equal to -1 is less than or equal to y, which is less than or equal to 9. When we take a look at this next slide, we're going to talk about parabolas. We have done a lot of work with vertical parabolas, and vertical parabolas open up and down are always set equal to y. We haven't learned about horizontal parabolas, so this is new. Horizontal parabolas open left and right, and they are always going to be set equal to x. Your vertex, however, is always still at HK, so you need to pay close attention whether it's vertical or horizontal in order to determine whether your H is on the inside or the outside, and vice versa with your K. So the first example, the parent function is y equals x minus 0 squared plus 0 is shown to the right. They then want us to find the vertex graph and describe the transformations and the domain and range for the quadratic function y equals x plus 2 squared plus 4. So the first thing that I notice is it's set equal to y, so my parabola should open up or down, which means my h is always associated with my x, so I have a plus 2. So my transformations mean I'm going to move left 2. And then my plus 4 on the outside is associated with my k. I'm going to move up 4. So from my original vertex, I'm going to go left 2, up 4. I now have my new vertex at the ordered pair negative 2, 4. I can then graph it using my pattern over 1 up 1, over 1 up 3, over 1 up 5 that we used previously. You could also make a table of values if you don't remember that pattern. So when we take a look at our domain and our range, our domain pertains to our x values. So when we look at our graph, the smallest x value and the largest x value are both arrows, so our domain is all real numbers. Our range pertains to our y values, so we look at what is the lowest that our graph goes, what is the highest our graph goes. So we have y is greater than or equal to 4. Looking at the next example, we notice that it opens left and right. You can also see that it is an x equals equation. So be very careful that your k is now on the inside and going to be the opposite. Your h is on the outside, and remember, the outside stays the same. So the transformations, a negative 3 is going to move our graph up 3, and this positive 2 on the outside is going to move our graph right 2. So from our vertex, if we go right 2, up 3, we have our new vertex, which is 2, 3. We then graph it using our same pattern, over 1, up 1, over 1, up 3, over 1, up 5. We mirror that across our axis of symmetry, and we have just graphed our quadratic function. When we identify the domain or our x values, our smallest x value is positive 2. Our largest x value is 0, so we want to say x is greater than or equal to 2. When we look at our range, we see that our largest y value and our smallest y value are both going towards infinity, so it is all real numbers. When we take a look at our third type of conic function, we have an ellipse. Notice it is the quantity of x minus h squared plus the over m squared plus the quantity of y minus k squared over n squared equals 1. Our center, you notice, is still at hk. Insides are opposite. It is going to stretch m units horizontally. So whatever is underneath the x is going to stretch horizontally. Whatever is underneath your y is going to stretch vertically or up and down from the center. Looking at this example, the parent function is shown to the right, and they want us to translate it for our new function. So this negative 4 is related to our h and is going to move our graph right 4. This positive 2 is associated with our k, which is going to move our graph down 2 because inside parentheses is always opposite. So if we go right 4 down 2, we have a new center at the ordered pair 4, negative 2. We then look at the square root of 9, and whatever is underneath the x is going to move horizontally, so we can count 3 units to the left, 3 units to the right. we look at the square root of what's underneath the y to stretch vertically. So we are going to count 7 units up and 7 units down from our center, and we just translated our new ellipse. When we look at the domain and range, remember the domain is the x values, the smallest x value that our ellipse touches. Look at your points, not my graph that kind of surpasses. So 1 is less than or equal to x, which is less than or equal to 7. My range are my y values. So my highest y is at 5, my lowest y is at -9, so -9 is less than or equal to y, which is less than or equal to 5. Our last type of conic function is a hyperbola. Notice that the equation is very similar to an ellipse, however there is a subtraction sign in between the two ratios. If your x comes first, then your hyperbola is going to open left and right. If your x comes second, so that it is negative, it is going to open up and down. Notice your center is still at HK. If it opens left to right, you are going to look at what is underneath the x to determine how many units from the center the two closest points are. If your hyperbola opens up and down, you are going to look at what is underneath the y, or the n squared, to determine how far your 2 points are from the center. Looking at the first example, the parent function of the hyperbola is shown, and then we are going to translate that. So our x comes first, so it's going to open left to right. Inside is opposite, so this is going to move left 2. For our y, inside is opposite. This is going to move down 3. So our transformation from our center is left 2 down 3, which gives us a new center of -2, -3. We then need to, because it opens left and right, we take the square root of 25, so we are going to count 5 units left and right. And then we are going to make our horizontal little curves from those points. When we look at the domain and the range, the domain pertains to our x values. We see that our x values are less than 7, so x is less than or equal to -7, or x is also greater than or equal to 3. When we look at our range, we look at our y values. We see that our y values are going to go to infinity in both directions, so it's all real numbers. Our next example is also a hyperbola, but you notice that y comes first, so your x is negative, and it is going to open up and down. We're still looking at our h, k for our center, so this time be careful, k always pairs with y. And h always pairs with x, so the inverse of -5 is k is going to move up 5. The inverse of +3, we are going to move left 3, so it's opposite what you think. We then, from our center, if we move left 3 and up 5, have a new ordered pair, or a new center at the ordered pair -3, 5. We're going to look at the square root of what's underneath our y, which is a 1, so we're going to count one direction in both ways, up and down, and then we are going to make our curves for our new transformed hyperbola. When we look at the domain, remember we look at the x values. In this case, our x values are all going to positive and negative infinity, so our domain is all real numbers. Our range, however, when we look at the y values, is going to be greater than 6, less than 4. And you just graph this hyperbola.